Okay, today I'm going to present about problem analysis. Okay, step 2. Design a solution. Design a solution involves creating an algorithm. An algorithm is a sequence of well-defined steps to solve a problem. An algorithm can be represented using pseudocode and or flowchart. Okay, algorithms. A sequence of well-defined steps to solve a problem. A good algorithm must satisfy these requirements. Input. It must have input. It is conceivable that an algorithm may have no input. However, such algorithms are trivial and quite rare. And the output. It must produce at least one output. An algorithm that does not produce anything is worthless. There's two techniques that can be used to represent algorithm. The first one is pseudocodes and the second one is flowchart. The main purpose of a pseudocode is to define the procedural logic of an algorithm in a simple, easy to understand for its readers, who may or may not be proficient in computer programming language. Okay. See, this is the sequence of the pseudocodes. To do pseudocodes. In writing a pseudocode, one should start by analyzing the problem statement. Okay, first we start with the problem statement and the problem analysis and go to the pseudocode. Okay, this is the general format for pseudocode. Start, we first start with start and then we do the input, or we can type also read or get input, and then we do the process, the formula and the condition, and then the output, display or print out output, and then last we do the stop. This is the example of a problem analysis to pseudocode. Okay, the problem analysis, the input is number, the process is calculate the square of a number, and the output is square. Okay, the pseudocode is start input square the process equal number times number, the output square, and then stop. So this is the full pseudocode. Find the square of the number. Okay.
I will continue this step with flowchart. Flowchart is a set of standard shape boxes that are connected by flow lines to represent an algorithm. It is easy to understand type and flow of instruction in graphical representation. In an alternative to pseudocode, where a pseudocode description is a verbal, a flowchart is graphical in nature. So these are flowchart symbols. The first one is a terminal symbol, indicate the beginning and end point of an algorithm. This is process symbol, shows an operation other than input, output, or selection. This is an input-output symbol, shows an input or an output operation. This is this storage input or output symbol. It is a cylinder shape, indicate input from or output to this storage. This is printer output symbol, shows hard copy printer output. This diamond shape is decision symbol, shows a selection of process. These two parallel arrows are flow lines, indicates the logical sequence of execution steps in the algorithm. This is off-page connector, provides continuation of a logical path on another page. The circle symbol is on-page connector, provides continuation of a logical path at another point in the same page. This is an easy example of flowchart. We begin with the begin, which is using the terminal symbol. Then read birth rate. This is the input, and calculate age equal to current year minus birth date, which is the process symbol. And this is the output, and this is the end. This is another example. Example of flowchart with the decision, symbol. Let's see. Begin with age and the decision symbol if age is over 55. If bigger than 55, I'm sorry. There's decision, which is yes and no. And they will go through, if yes, they will go through the print pension, which is in the output. If it's no, they will print kerja lagi in the output. So this is another example. Start off with a begin, and this is sum equal to 0, current number equal to 1. So they went to here, the decision symbol. If current number is less than 10, if it's a no, then it will print sum. If it's not, it will keep adding based on the formula, which is sum equal to sum plus current number, or current number equal to current number plus 1. It's looped until it's printed sum. Okay, this is the way to okay, so this is an example of how to solve a problem use algorithm. So print negative if user enter negative integers, print positive if user enter positive integers, and print 0 if else. So this is the IPO. The input is integers processed to display positive or negative or 0 based on given integers. The output is positive, negative, and 0. And this is the pseudocode. We start with the start. This is the process, rate integers. If integers larger than 0, then print positive. If else, integers less than 0, then print negative. Else, print 0. This is the process. And if, stop. Okay, and this is the flowchart, which is almost the same as the pseudocode, but in a graphical way. Let's start with integers. If integers larger than 0 is true, print positive, then it will stop. If it's false, if it's not larger than 0, if it's less than 0, it will be false, and it will go to the decision of if integers less than 0. If it's less than 0, it's true, then it will print out negative and stop. If the integer is 0, then it's false. It will directly print 0 and stop the process. That's all from us. Thank you.